go into a little bit more of playing those sounds later, so we'll skip the rest of that recording that I had here. Now I'm going to play for you one of those songs very slowly and show you this sort of sonogram image that we've seen before. And we're going to follow along. We're going to be able to see the phrases, the elements that the bird's using as they pass by. Now this is fascinating because if you listen to the sound quickly, actually the speed at which the bird actually sings it, you're going to miss a lot of this. So you hear at the end it's a that was the Okay, so I wanted to analyze the rhythms that the bird uses, particularly when they use a duo rhythm. So they use two sounds with an offset rhythm like da-da-da-da-da-da-da-da. Here's some examples of just rhythmic groupings. The bird has all sorts of interesting rhythmic groupings in twos and threes and fours and so forth. I'm going to play a few. So at the top here, here's a rhythmic grouping at normal speed in threes. You don't hear the threes. Here's what it sounds like slowed down. And then another rhythmic grouping of threes, but a different type. Again, it's hard to hear the threes, but here they are. Man, if there's anything to say about this bird, it grooves. Okay. So the birds have all sorts of types, like I said. We have groupings of twos at the top there, groupings of threes, groupings of fours. They even have these really interesting complex groupings of twos within three that you see there at the bottom. So what I wanted to say is, okay, I'm a musician, I'm trying to connect birdsong with human music. I know that in human music we use something we call simple integer ratios in music. And that just basically means that in rhythms, which I'm exploring, we have a regular pulse, and the points at which we have silences are marked by the pulse that's going underneath. And I'll go into detail about what that means here. So for example, here's a cycle that's divided into 3 parts rhythmically, and I'm going to demonstrate, this is the image that will represent that, but I'm going to demonstrate with sound how that sounds. 1, 2, pause. 1, 2, pause. 1, 2, pause. 1, 2, pause. Okay? So this small iteration concept may sound complex, but that's basically what it means. We can divide a repetitive sequence into pieces of a similar size. So in music, and in the rhythms of music, of human music, we see these very simple ratios, and that is, 1 out of 3, which is the first one, 1 out of 4, 1 out of 5, 2 out of 5, and so forth. And I'll just show you here an example of how we represent a 3-based rhythm here in a circular format. I'll use these plots later. So for example, this is if I'm going 1, 2, 1, 1. That's how it would look on the plots I'm going to show you. And I'll skip the example. Here's a grouping of 4. That's if you said 1, 2, 4, 1, 2, 1, 2, 4. And I think you guys get the concept. So I'm going to move on, and I'm going to ask, what did the birds do? Did they use these simple integer ratios or not? And the results look like this. So here are representations of the divisions that the birds use. You can see they're fairly widely distributed. Let's look at our simplest ratio. That's of 1/3. Okay? So it looks like birds actually use this 1/3 ratio quite commonly, but there's a lot of other stuff going on. Let's check the other complex ratios. So here in green you see the ratio of 1/4. Okay, that's there, but there's still a lot of other stuff. And then we even see ratios of 1 out of 5 and 2 out of 5. 2 out of 5 is a very interesting rhythm. It goes like this. Interesting to know that the birds are doing complex rhythms like that. But you can see there's still a lot of things left over. I looked for these integer ratios in the birds, and yeah, I saw some peaks in the histogram around the 1/3. There was a wide variety of things that were going on. I looked across different types, and I continued to see, yeah, I see peaks, but that's not exclusively what the bird is doing. So this is frustrating to me as a scientist, right? I want it to fit my model. And so I got frustrated, and I went and I listened to actual music. I said, well, how do musicians actually do this? And so I went to a classic recording of Miles Davis, and I took a track from that, and I said, what's the ratio that the drummer plays on the rise cymbal? Because that can be divided into twos. Those are like twos there. So let's listen to that. What is it? Where does it lie on this plot? Oh, it lies right there at the 1/3. So that was kind of disappointing, right? I was hoping it would do something, you know, a little bit more variety. Well, let's take another track from the same recording. This is a lot slower. Now, where does the drummer lie on the plot in this example? Interestingly enough, quite far over here. All right. And I looked in the literature on human music, and what did I find? There's actually a wide variety of ratios that drummers use when they're playing jazz rhythms. Even though it's notated very strictly as a sort of 1-to-3 ratio, they are using a ratio where the long part is longer in the slower recordings, and in the faster recordings, the two parts of the beat become more equal. All right, it's actually a very interesting, very clear regression line that goes through those points. So, and I thought, okay, well, all right, maybe the birds are doing that, and it turns out they're doing exactly the same thing. So, when nightingales group rhythms into twos, they make the long part longer at slower speeds, and then as they approach faster speeds, they make the two parts of the rhythm more equal in length. Okay. Very fascinating result. And I'm writing a paper up on this, and we're sort of exploring, you know, what kind of things are at play here, production mechanisms, preferences for perceptual preferences, and so forth, and looking at different sounds that the birds are making and other rhythmic groupings. So there's the two plots together. It's really uncannily similar. And that's the thrush nightingale, and I'll play a little bit with this guy for you.